So on the second part of the solution experiment, we will prepare a buffer solution, and from your laboratory PDF file, you can see that we need two solutions and we need to mix two chemicals. One of them is acid, and we will use acetic acid for this, and one of them is the salt, and sodium acetate are our material for that. Sodium acetate is a solid, and we need to dissolve it in the water in the calculated amount. So it is very similar to the sodium chloride experiment we done previously. So I prepared it earlier. Now this solution has sodium acetate in it, and how much is it? It is 0.857, so it is all in your PDF files. Now I have my salt here, and from the equation I know that I also need a second thing to make a buffer, and it is acid. And again, from my calculations, I found how much acid I need in grams, and by using density, since it is liquid, we transformed it to the volume, and I know that 211 microliter acetic acid is needed to make this buffer. So here is micropipette. It can take liquids between 20 and 200. So I will make it to take 100 first, because it can't take more than 200. I need 211, so I will put 100, then 111. So it will be total 211. So first, I'm carefully taking 100 microliters and putting here. While putting here, I am not touching any liquid, any solution, because I want to use this pipette again to enter the acetic acid. If I contact my pipette tip to this solution, I need to change it, okay? Every time you can't use your same pipette tip with different solutions, because you will carry some liquids and it will contaminate your sample. So I put 100, now I am putting 111. I changed my thing, so I can now put it inside. No problem, because I am not going to use it, so it is waste. And I am closing my stock solution. So now here I have my salt, I have my acid, and all in calculating amount. The final thing I need to do is making it 100 milliliters. So again, for 100 milliliter solutions, I am using a volumetric flask. So it is 100 milliliter flask. It has a line here in the neck. I will first decant everything here. And then I will add water. Here is my line on the neck. So slowly I am putting . Okay. So first I had my salt pre-weighed, then I added my acid. Now it is 100, and now I can make it more homogeneous by inverting upside and downside. Also I'm pressing here on this lid, because if you don't press here, it can go off and your liquid maybe go west. In the previous experiment, I was labeling it. Now I will use it, so I am not labeling. So now I can calculate the pH. If we did everything correct, that means we will have pH 5 because the amounts we used for pH 5. Now it can stay here a bit, and I will introduce you to pH meter. So this is pH meter. It has a something called electrode or probe, and it measures the pH. And this probe is always stored in some solution, a protective solution. And this protective solution is here in the bottle. You can see there is a little amount of solution here. So first I carefully remove my solution. I'm careful because this bottom of it is glass, made of glass. I am putting my solution away. So my electrode is made of glass. I need to be careful with it. Now before measuring anything, since it was in protective solution, there are some parts of protective solution upon it. I need to wash it first. I am using a beaker for waste. I am taking my water and I am just washing it. So I am using pure water, so I can get rid of the protective solution, which is 3 molar potassium chloride. Now it is cleaned. I can use this to calculate, and my solution, buffer solution is here. So let's hope to see pH 5 here. When I am dipping it, I am not going all the way down. It shouldn't touch anything, shouldn't touch the nears, shouldn't touch the bottom. If I go fast, I can break the glass. So slowly I am dipping it. I am not just touching it, I am dipping some to some context, but not touching anywhere, okay, in the middle of it. So here on the pH meter, now it is calculating and numbers are changing, but it shows me 5.09 now. So even it changes, it won't go far. It won't go like 3 or 7. That means we are close to our goals. We were trying to make 5. So it is 5.6 now, but still measuring. 5.5, I mean 5.05, not 5.5. So it is very close. Yeah, I guess it doesn't change. Yeah, and there is a line here. I can see it is 5.05. So we were very close to our goal. First I will clean the electrode. Before putting it back into protective solution, now I have my buffers on it. So I need to wash it again. Before and after every use, you need to wash your pH electrode. I washed it and now I am putting it slowly to my protective solution. So it is ready to be used in other experiments. And that's all.